let's dive into one of those classic programming debates, abstract class versus interface. This is something that I guarantee you trips up even seasoned developers in technical interviews, and for a really good reason. At first glance, they look so similar, don't they? Especially with newer Java features blurring the lines. But here's the deal, they are built for fundamentally different things. And picking the wrong one, it's not just bad style. It can literally break your design and lead to a world of pain down the road.
So that's the big question, isn't it? When do you reach for an abstract class, and when is an interface the right tool for the job? Well, that's exactly what we're going to clear up. By the end of this, you'll know precisely which one to choose, and more importantly, why.
To really get this, we have to start with the core concept, the main philosophical difference between the two. Here's the best way to think about it. An abstract class is like a partial blueprint. It can give you some of the structure, maybe some of the code is already written for you, but other parts are left blank for you to fill in. An interface, though, that's a rock-solid contract. It just lays down the law. It says, here are the rules. If you sign this contract, you must provide an implementation for all of these things.
Let's look at a real example. See this animal abstract class? It's got a mix of things going on. The sound method is abstract. It's just a placeholder, a rule. But look at the sleep method. It's already got code. That means any class that extends animal, like a dog or a cat, gets that sleep behavior right out of the box, completely free.
Now let's flip to an interface. It's a totally different story. Traditionally, it's a pure contract. It just lists what an animal should be able to do, make a sound, and eat. It provides zero implementation. It's just a set of promises. Now, I know what some of you are probably thinking, wait, what about default methods in Java 8? And that's a great point. They do let interfaces have some code, but the core design purpose is still worlds apart. Okay, now we get to a hard and fast rule. There are no exceptions to this one, and honestly, it's often the single thing that makes the decision for you.
So let me ask you this. You're building a new class. Can it inherit from two different abstract classes at the same time? What do you think?
And the answer is a big, fat no. Not for abstract classes anyway. A class in Java can only have one parent. It can only extend a single class. But interfaces? A class can implement as many as it wants. That flexibility is a total game changer. So if your object needs to wear many different hats or satisfy multiple contracts, interfaces are your only way to go.
All right, so we've covered the technical rules, but the real secret to mastering this isn't about memorizing syntax. It's about a way of thinking, a design philosophy. And here it is. This is the simple mental test you can use every single time. Ask yourself, is this an is-a relationship or a can-do relationship? A dog is an animal. They share a core identity. They're part of the same family tree. That screams abstract class. But what about a bird, an airplane, maybe even Superman? They aren't related at all, but they all share the capability of being flyable. They can do the act of flying. That is a perfect job for an interface. Let that one sink in. If you walk away with just one piece of advice today, make it this. Abstract classes are about identity, about what something is. Interfaces are about capability, about what something can do. Identity versus behavior. That's the whole ballgame.
All right, you think you've got it? Let's put that new mental model to a quick test.
So you're designing a system. You've got birds, planes, drones. All these unrestricted things need to fly. Should Flyable be an abstract class or an interface? Well, a plane is not a bird, right? It's a capability they both share. So of course, the answer is an interface. Simple as that. Okay, let's put this all together and wrap it up with the ultimate cheat sheet. Think of this as everything we've just talked about, all in one place. This table lays it all out. You've got the keywords, extends versus implements. You see that abstract classes can have constructors, while interfaces can't. But the two rows you really need to burn into your memory are state and inheritance. Abstract classes can hold data. They can have instance variables. Interfaces are stateless. And as we've hammered home, you can only extend one abstract class, but you can implement many interfaces. All these other little differences really just flow from that core distinction. So please, don't think of this as a competition. An interface is not just a better or more modern abstract class. They serve completely different design purposes. The question you always have to ask yourself is, am I defining a core identity or am I defining a capability? And there you have it. I really hope this cleared things up. If you found this useful, you'll definitely want to stick around, because in our next explainer, we're going to dive into the granddaddy of them all, the object class, and the powerful methods that every single object in your program gets for free, whether you realize it or not. I'll see you then.